Hey everyone, welcome to another episode of Hypermode Live. My name is Will, and today we have a special guest, Amy from GraphGeeks. Hello, Amy.
Hello, Will. Thank you for having me.
For sure, and thanks for coming on. Today we're going to talk about GraphRAG, agentic workflows for GraphRAG. Maybe see how this works in the context of agents, and talk about retrieval, why this stuff is needed. So I think this will be a really interesting one to dive into. But before we jump into that, Amy, maybe do you want to introduce yourself a little bit for folks who aren't familiar with you, or also with what GraphGeeks is?
Absolutely. So, my name is Amy Hodler. I am the founder of GraphGeeks. And just so everyone knows, Will and I have known each other for several years. We've worked together, we've presented together, had a lot of fun. And I founded GraphGeeks a couple years ago to be a vendor neutral community for people who love graphs, who are either practitioners, researchers, or people that just are fans of it. We have a lot of graph puns that happen on the GraphGeeks Discord. So we produce some videos, some training material, podcasts. And we have an active Discord as well, so that people can jump in and ask questions, whether it's a getting started question or a very deep technical query question, whatever it might be. And that's it. I will be 2 years old in October, by the way, so we're coming up on an early anniversary. Pretty exciting. And I've been into the graph space personally about 10 years, a couple different vendors, now vendor neutral, but have played around with both RDF graphs and label property graphs, and just love anything to do with network science and connected data.
I really like your community, the GraphGeeks community. I think there's a lot of discussion on Discord. I shared a link in the chat to the site, and there's an invite for the Discord. Where yeah, there's a lot of good discussion in there, which I think is fun. It's a real, I think, too, like, good natured community, right? There's a lot of folks like sharing what they're working on, and a good place to discover ideas. I'm really curious from your perspective, like, your motivation for starting this group and maintaining the community, right? It's interesting to see, what folks who organize these communities and that sort of thing, of like what they get out. I think everyone has sort of like different motivations, but could you speak a little bit about kind of what motivated you to start GraphGeeks and sort of nurture this community?
Yeah, I always chuckle a little bit at that question because I was a lonely, slightly introverted graph person. I think I think when you do graphs for a long time, or even not for a long time, you realize that the people involved in that technology, and actually network science and complexity studies in general, they see the world through connections and relationships. So they tend to be very nice, helpful people who are thinking about the bigger picture and community in general, which is just a nice place to start with. And I think you see that a lot amongst people who fall in love with graphs. And as I said, I've been in the graph space for 10-ish years, and had been at a couple different vendors. And then when I stepped out and was on my own for a little bit, I realized that I just very quickly missed having that community around me, and a community of people who have a same way of looking at things through connections and relationships. And I realized that there was no community out there that served graphy interest in general. Lots of vendors have really good information. They have tutorials, they have events you can go to, but there wasn't a spot if you didn't belong necessarily to one particular community. And I also think, as I stepped out of the vendor space, I realized there was just a lot for the different types of graphs and the different types of community to learn from each other. And I thought, well, why not give it a try? If I'm doing it on my own and I fail, nobody can fire me. So the risk of failure was zero. And I just started it up, and had a couple people reach out, and it just really snowballed quite quickly from there.
Awesome. Awesome. That's yeah, that's a great story to hear. Cool. Well, let's jump into our discussion around GraphRAG. I see some folks in the chat, so thanks for joining. We'll monitor the chat, but let's if we're open to it, try to keep it as interactive as possible. So if you have questions, comments, drop it in the chat. We'll be sure to get to that. To kick it off, I always like to ask folks to share where you're joining from, just because it's cool to see people joining from all over the world, but also gives me a little test that I can see the chat and that everything's working there. So thanks everyone for joining today, and yeah, let's jump into it.
Um, I think we're going to take a look at some material, actually summarized material that I recently presented with a group. And so I think 3-4 weeks ago, time goes by pretty quick. A group of us from GraphGeeks got together and submitted for training for the Agentic AI Summit, which is put on by the Open Data Science Conference team. And we did 3 trainings over 3 weeks. I'm not going to present all that material. I'm going to do some summarized material from that. You can go online and find some of this more detailed material online through the Agentic AI Summit. But we had 3 sessions. One was on designing for production. One was on building for production for knowledge graphs. And then the third was on evaluating and benchmarking results. And if you'll notice, all of these really think about production. And the reason why is there's a GraphRAG channel in Discord, of course, but there was a lot of discussion back and forth on what it meant to actually be successful with GraphRAG, and how it was more than a POC, and the lack of benchmarking in a lot of the projects, or the lack of good baseline graph material in GraphRAG, which if you don't have good graphs, you're not going to have good GraphRAG. So we had a lot of discussion about that, and then a group of 4 of us got together and said, okay, well, let's do some training on this. And this was kind of a summary of what that was about. And make sure I can progress. Yes, I can progress. And we started off by kind of looking at, and I think it's important to kind of look at what's the level set of interest. And so I did a little bit of research to try to figure out like what the market looks like for GraphRAG. And not surprising, it looks like it's huge and going to be large in general. And so if you're new to GraphRAG, and like why RAG in the first place, is RAG in general augments whatever your LLM has with external or updated data. So if you think about it, if your LLM has been trained on data from the past, it's also been trained on very specific data, and as people implement them, they either have updated data or they have other data they want to bring in. Maybe it's specific to your company, or somehow has to be contextualized, and so you get better results. It's more accurate if it's more contextually appropriate. But LLMs in general kind of struggle, and RAG in general still struggles to understand the actual meaning. And so this is why you hear a lot of people talk about semantics, and anything that's ambiguous. So results, or if you're pulling from data that contradicts each other, or it's ambiguous results, obviously that can be challenging. But you also have what I call, well, is called long tail events. So things that don't happen very often can also be difficult, to use RAG for. And so there's a number of different elements that actually limit RAG in general. Also context windows, which we'll talk about maybe a little bit later when we talk about memory. But there's these number of things that kind of limit where the plateau of RAG is happening. And that's really where things like graphs come into place. And so there's a really good blog, and I linked to it here at the bottom, on RAG, in where we are in the status of RAG. And I pulled a lot of this data from that post. So if you want to dive into it, it's a really good long post. But they talk about the innovations that are going to have to happen to improve RAG in general. And as I look through those with my graphy lens, I see a lot of graph and connected data in it. And the first one that they talk most prominently about is the semantic gap. And so that's, if you think about it, just like I said, to struggle to understand what meaning really is. And a lot of times your queries and your answers don't really align to the meaning that the person is actually asking. And so you can bring in things like GraphRAG, to leverage that structured data and structured knowledge to kind of bridge that gap between understanding and the relationships between what people are asking and the questions they're getting. But there are also other issues as well. There's data quality, of course, and that's something that we can see improving over time, especially as RAG is able to incorporate multimodal data as well, so different types of data. I'm really interested in image data getting in RAG as well. It's this kind of interesting trend. Retrieval effectiveness as well. So pure semantic search. So if you're doing a similarity search, can be really great at approximate matches, but not necessarily exact. And so adding in or contextually rich examples. So, having a hybrid search is something that we've seen perform a lot better. And then efficiency overall. I think there's some improvements there going on that aren't graphy, but that's something that I think is going to continue to improve. And then you have multi-step reasoning and context, which anytime you hear the word context, it's automatically a candidate for looking at it with graphs. And I think agentic RAG, hierarchical indexing, graph memory, these are all ways that multi-step reasoning and context can be helped with. So that's kind of the big picture of like where, in RAG, like where it's at, why we've hit a little plateau, the fact there's a lot of different things happening right now to improve it. I've highlighted in red the two like super graphy ones. We're going to talk about GraphRAG in general on that. And I'll just pause for a second and say, Will, is there anything that you're seeing here that you want to add as far as kind of overcoming the RAG plateau?
Well, I see a question
Oh yeah.
in the chat here. Maybe now's a good time to take this. So you mentioned, this idea of image data and including that in the RAG
Mhm.
process. Could you speak a little bit more about maybe like I don't know what's the benefit of that, and are there specific use cases this would be
Yeah.
relevant for? Could you just maybe say a little bit more about and like how we would leverage image data in GraphRag?
Yeah, so there is actually, I've given a talk and done a little work with a colleague of mine, David Hughes, on multimodal graph RAG. And the use case, we're combining vectors and graph together, which we're doing a little bit in the example we're going to show here as well. But what we did in addition to a typical lexical graph is that we actually graphed images. And so if you think of an image, and I think the latest use case we did an image of a park, and we also actually probably a better example is an image we did with a fleet of ships. And so if you think about a fleet of ships and you've got a picture of a fleet of ships, so imagine a bunch of ships, waves going by, if you graph those, the spatial relationship can be seen as relationships. So you might have a battle carrier in the middle, and you might have a different. And I don't know my ships, so apologies here. But you might have a different type of ship off to the side, the upper to the left. You might have one that is behind. You might have a ship that's in front. All of those spatial relationships actually have meaning. And if you can look at those over time, you can also do things like estimate the speed as well of the ships relative to each other. You can look at the elements of the image and look for other formations that are similar based on the topology. And so if you look at again, the spatial relationships, your nodes in this case are ships, their spacing between each other are the relationships, and you can look for other configurations. Maybe that configuration actually means something that actually indicates they're moving in a direction or they're preparing for a certain type of formation. So that's one example that you can do with GraphRAG. We also did one with a park, and you can imagine the different meanings it might have to how people are standing together in a group. Maybe that indicates a intimate conversation versus a disagreement, or the body language. Images have meaning, and you can do this as well with audio, which gets into a whole other area. But audio also has a lot of meaning, and I think when we think about multimodal graphs, and I would say multimodal graphs, not just GraphRAG, we are historically in the graph space very, very used to having text in graphs, lexical graphs, and we were very, very used to mathematics in graphs. But we really haven't gone that far in trying to lay out an image and the relationships in an image as a graph, and the same with audio. And I think that's a very exciting area, but it's also super nascent. So I learned of one startup yesterday that is actually trying to do something with this, and then David and I as well, just playing around with this concept and trying to kind of push the boundaries of what's possible. So I appreciate the question, because it's a super fascinating area. It is really nascent, and if you ping me later, I can send you the resources that I have on it. Yes, absolutely. So the follow-up question is about, in addition to the, oh, thank you for highlighting that, Will. So yes, in addition to embeddings, we actually use embeddings in a vector database, and then we use the relationships in a graph database. And so we blend those two together. So it's super cool. And I'm happy to follow up on that particular topic as well. So maybe we should keep going, Will, so we get to traditional GraphRAG, if that's even a thing now. Is it traditional? It's been around for 6 months. It's old school.
That's right. Exactly.
Okay. All right. So I think enough on multimodal, as much as I could talk for a long time on that. So why graph and GraphRAG, I think, is another thing to take a look at. So what do you gain with graphs? You gain structures, relationships. You potentially gain multi-hop reasoning if you have to bring together multiple documents and do things that are more iterative and long-term tasks. You can also incorporate multiple different types of data if you're using a graph systems are good for that. And then anything that is highly relationship-based, you would assume is going to be better in a graph if you're kind of traversing through ideas, and just more explainability with contextual interpretations. Now, those of you who are graphy people already probably look at a lot of this and say, yeah, that's what graphs are good at. Of course, that would bring it. But if you're not familiar, these are kind of the typical things that graphs are good at that you can bring into your RAG system. I put a couple links at the bottom. These are probably mm, 9 months old as far as when these reports came out. Maybe a little more than that, but they just give you some examples of GraphRAG actually improving either answer rate or resolution times and things of that nature. So that's basically why people are adding graphs into what they're doing with RAG already. Um, the challenges that we see around it have less to do with the concept and more to do with the execution of building, quality graphs and putting them into production. So to look at that and to kind of look at like why that is, I think building quality graphs in general is a rather nuanced thing. And so anybody who's been in the graph space in general know that it does take a little bit of knowledge, and in particular, building out that schema. I almost said screama. The schema and graph modeling usually takes a little bit of experience. There's a lot of choices out there, and it's often specific to your use case. Now, there are, people who are promoting using LLMs to build your schema. I would say that might be a great way to get away from the blank whiteboard problem of I just don't know where to start, but you're still going to need a human involved to improve it and tailor it to what you need and to do it efficiently. And part of the challenge is there's not often as much expertise in the graph space as there might be with your general machine learning teams. So they might have some experience or a few classes in school, but maybe haven't been building these. And it does take your domain expertise as well, because that is a part of doing a good data model. So you need to bring in those folks early on to help build your good graph. The other thing is there are emerging standards. So out there, we won't get into the difference between the different types of data models, but there's different query languages, there's some standards developing, but there's also a proliferation of options, which is great because you have all these different options if you are trying to do something that's really implemented inside of a bigger agentic workflow. Maybe you're using something like Modus and you want to use a dgraph, or maybe you need something that's in a highly regulated environment and you have to use RDF. So there's a lot of choices out there, but it does mean you have to kind of think about what fits into your bigger life cycle, and not just GraphRAG as well. So those are kind of like the basic, the basic things that people struggle with a little bit on just building a good quality graph in general. Um, and the other thing is, how do you know once you have built this graph in a GraphRAG system, how do you know if what you've done is any good? And this is something that we thought a lot about, because if you can't measure quality, it can be difficult to know where to go. And I will say I do talk to people a little bit about being careful of GraphRAG disappointment, and this is the classic garbage in, garbage out. So what I was just talking about, building a good graph can be a little nuanced. And if you build a really bad graph, you're not going to have good GraphRAG and good retrieval, especially if you have bias in your models, if you have a lot of dirty data. So, just that you don't get away with that just because it's the latest coolest thing, GraphRag. Um, and this can lead to all sorts of inconsistent results, which can be a killer for production. So even if your POC works well, you get into production with a variety of data, and if you're not sure how to measure it, then you get inconsistent results. And if your schema is not aligned to your data, your questions, and your LLMs don't semantically match what you get this rippling effect. So, just be, prepared that you really need to measure so you don't end up with, disappointment later. And then the question comes, well, like, how do I measure? And we can test kind of naive retrieval, but there's no agreement right now on what or how to measure, the GraphRag quality results today. And there are I saw a talk that's being proposed for later in this year on a standard measure for GraphRag. I'm hoping that actually happens. I'm kind of excited by that. There's a couple of vendors looking at that. But we need benchmarks, and we just don't have a lot right now, but I think they're coming. And the other thing is there's also evaluation and production and ongoing monitoring as well, which is developing. There's been some really good work done. In particular, I've seen some nice work in using OPIC to do ongoing measurement. So we need to measure. There's no standards exactly on how to measure, but it is coming, and we're going to definitely see this. And then, of course, things that you might not expect, which is data extraction is not always reliable. So it's common when using an LLM that doesn't see an exact match. You might get like something like an empty response because it doesn't have an exact match. We also have to deal with data that's always shifting. There's this concept drift or data drift that we talk about in machine learning. Same thing's going to happen here. So, of course, you have to have that again, ongoing monitoring, but also things like ongoing schema maintenance. So a schema is not just a one and done thing. It's something you have to manage over time. And I see that Veronique, hello, Veronique, has a question about bias and modeling as well that results in bad graph RAG results. So if we think about, data, and I assume, Veronique, I'm going to answer this for, graph modeling. So anytime, or schema modeling, so anytime you're making choices on what you index, how you model in a graph, you're making a choice on what is or isn't important. And so you may decide that gender is a two-value option. In fact, we were looking at data recently, and some of the data that we were looking at actually for this training, it only had two genders as an option, but you could see from some of the text that there were entries that had other options as well. So they had a kind of a they them option as well. So something that was a little more fluid and nuanced. Um, but that wasn't in the schema of the original data. And so even the choice of what you decide to label, or what you decide to, do your schema around, will influence the LLMs and how they respond. And you can use your schema to encourage, sometimes I say coerce, your LLMs to kind of move in a different direction. But anytime you do any kind of fine tuning or any kind of selection of data, you are introducing some bias. So I guess it's just to be careful in thinking about that. All right, so let's look at the next option here, or the next topic, which is all about GraphRAG and agentic workflows. And I would say GraphRAG is inherently agentic. So if you build to orchestrate the steps to enhance your GraphRAG retrieval, or you want to do that, it kind of is it's a very back and forth process. So one of the things, when I first started hearing about and thinking about GraphRAG, and I was very skeptical at first, but I often thought of it as, the graph is just one is at one point in my process that I will do some graphy stuff, and then other things will happen. But what I really found was that graphs and agents can go back and forth in this process, and it's better when you do go back and forth. So you can think about things like, routing the query to the appropriate tool or workflow. So, for example, text to cipher, or some kind of templated cipher with parameters you might route towards. You definitely want to reduce the likelihood of empty responses, so that can be a problem. So if the LLM doesn't see data, we can monitor and augment with like a fuzzy search. So you could then bring in a vector in that case. Error handling recovery. So, for example, if you have incorrect cipher, I'm sure that never happens. For a query that's written by LLMs, you can actually use some agentic workflows to correct or try to correct some of your queries. And then I also think that you can use graphs towards the end to re-rank results. And there's some interesting work in memory, graphs as memory as well, that uses graphs to also re-rank results, which I think is really interesting. But you could, for example, in your results, you could prioritize your results based on like a page rank of the keywords that are in it, or something like that. So there's just a lot of things that you can do to have graph and graph RAG and agentic workflow kind of go together, hand in hand. And so I guess the summary on this one is, just don't think of it as a one and done process or option, with graphs going back and forth. Um, and there's a question about financial, I assume, agent workflow. I'll get to that a little bit later, and if I don't, just remind me, and I'll try to follow up with that as well. So one thing I do want to mention is there's a lot of debate on, if is this really agentic? It's not agentic unless it's like all steps are completely agent controlled. So I think of agentic applications as a sliding scale, I guess, of autonomy. And so Anthropic defines workflows as systems where LLMs and tools are orchestrated through predefined paths. To be fully agentic, they, on the other hand, they define that as systems where LLMs dynamically direct their own processes, have autonomy in decision making, they maintain control, they accomplish tasks. And so this really gives, the LLMs that, the high degree of self-control. I think of it more of a sliding scale, and I don't think I don't think you ever really want fully one way or the other. And so there's always trade-offs you have to make. And so what we talked about in the workshop and the training is, first grounding material to be LLM and agentic workflows rather than fully agentic. And this is really so that you can start off with more control, evaluating each stage, establishing the behavior and the baseline you really need, and then go on and make it more and more agentic and give it more autonomy. So just, just take it in baby steps and, start off that way and then build up as you go. And so, with that in mind, we really talked about having this systematic approach for more quality GraphRAG. So thinking about production, systematic versus ad hoc, focus on your schema, your agentic workflows, and validation in general. And so if we think about, and I think I talked a little bit about this earlier, LLMs and agents for graphs and schema, and then to get us to good RAG, just that infinite loop of garbage in, garbage out. Just be thoughtful of that. You can use your LLM and agents for assisting with schema and graph creation. Um, Things like suggesting schema definitions, really good at that, extracting and loading entities, relationships, suggesting properties, inferring attributes, all really good uses for LLMs. But as you're developing your schema, I really strongly recommend human oversight, and maybe that'll change over time. But right now, you want somebody who actually understands the data and what's important and what's not. To Veronique's question about bias, like where do you want to emphasize and where do you not want to emphasize things? So incorrect models can have a rippling effect, and so you want to kind of get ahead of that, get ahead of the model early. So thinking about things like resolving ambiguities, and a lot of times humans are much better at nuances and things that have double meanings. Product to a technical person, a manufacturing person, probably means something different than product to the marketing person, and it probably means something different than product to the salesperson. So, which product are we talking about, and are there sub products, and all of those things that you have to understand the business and nuances. And I think that can help. I always think of it as like untangling relationships as well. And so this is my ploy or my plead for, at least for now, for involving humans in the loop. Some of my favorite, I guess, rules of thumb, I guess if I had seven thumbs, I'll say seven rules of thumb to keep a human in the loop in designing your schema. The first is always look at the purpose. So I hope that sounds obvious, but the most crucial principle I would say is to model for the domain that you're in, not the data. That can be really tempting to just model for what's easy with the data. And this is again where LLMs and agents can assist you in looking at it. But this also means understanding, the relationships and the entities that are in your problem space, independent of how they actually might be stored, and making sure that your schema reflects like the real world system that you're trying to model. Of course, relationships matter, and unlike a relational database where relationships are implicit, using foreign keys and things like that, graphs kind of elevate that to a first-class citizen. So when you're designing, you want to explicitly define the types of relationships, directionality, things of that nature, and that carries a lot of meaning, in and of itself. The other thing that maybe people don't always think about is balancing nodes and properties. I've seen graphs with like nodes for everything. So nodes are the entities, and relationships are the links between them. These, at least in a property graph, all have properties, but I've seen ones where people have like node all the things, and then other groups where it's like you have a million properties hanging off both your nodes and relationships. Neither one of those is a good idea. You want to balance. So, each node should have a label that categorizes it like a product or a person or an order. But they can also have those properties. If you're using key value pairs, describing attributes, person.name, product.price, avoid putting or stuffing too many properties into a single node or making everything a node. You have to balance. Otherwise, your queries are really going to suffer. The other thing to think about is granularity and normalization. So denormalizing is often beneficial for graph performance, but if you excessively denormalize, you all of a sudden have less flexibility and the schema is harder to maintain long time. So again, balance here. And then consistency and constraints. I thinking about maintenance, I always think about like long term, like beyond the POC, and this is again about production. So even with the flexibility of graphs, it's important to think about enforcing some kind of data consistency when you need it, and this maybe involves some like uniqueness and constraints. So you might say, hey, certain node properties are unique, user.email. Maybe you want someone to have a unique or user.social identification number, social security number, something like that. You maybe want to have a unique value. Existence constraints. So perhaps you have to have certain properties on certain nodes. So maybe a certain node label, like a person, has to have a property which is ID, and that has to be unique. Relationships can also have constraints. So you might have certain specific types of relationships that are required, or properties in relationships, just like with nodes. The other thing is to think about optimizing for queries. So you will have either humans or LLMs querying these graphs, or you bringing in that data. So how your data will be used and queried. Again, this kind of goes to point number one: fit to purpose. So think about things like indexing. If you're going to frequently use something, you perhaps want to index on that. Um, uh, Path traversal efficiency, so looking at designing relationships for really common queries or common traversals that you think your LLM may make, and of course whether any relationship values may have. So starting simple, just like this seems like a lot, and I'm doing a lot on this because I think there's a lot of good meat to think about, and I would say start simple, iterate. Nobody ever gets their schema right on the first try. I don't believe it. If you think you do, you probably haven't tested enough. You will probably evolve it over time. I threw a couple resources in on this slide because I think it kind of just gives you a good starting point. There was a interview I did with Max Lady. This is the visual here of the side-by-side method. I really like it, where you're actually looking at schema and full-on visual graphs side by side. This one is really great for teams that think differently, and it just saves you time down the road. But there are some other resources as well, including schema.org, which gives you a lot of example schemas to get started with. So I realize I've been talking for a long time. I'm going to pause afterwards. Veronique, we will make slides available. I'll drop a link in either now or later. I will definitely add it to GraphGeeks. And yes, Raymond is talking about needing different types of graph databases, or not graph databases, but different types of databases, embedding, graph, roles, permissions. So you may need different systems to control different types of um, functionality. I am definitely seeing that that scenario, Raymond, where you've got something specialized for a vector retrieval, you have something specialized for in the embeddings, something specialized for graphs, and then your roles, permissions, etc. However you would normally handle those. There are systems that try to combine some of these. I don't have an opinion on whether that's ideal or not. I don't know if maybe Will, you have an opinion on combining vector and embeddings together with graph. I know there are systems out there that do that, but in my experience, I tend to be using them separately, but that just might be what I'm familiar with.
I think vector search has become like a feature of most databases
Yeah.
these days, and including graph databases. I think there are certainly cases for using the more specialized vector databases. If you have like very, I don't know, specific or advanced maybe types of similarity search that you want to do, or you're working with maybe some like complex strategies. But I think for getting started, leveraging the vector search built into most databases now, especially graph databases, I think makes sense for getting started with GraphRAG. I tend to think of the vector search as like just another index into your graph. And so with a graph traversal, when we're querying a graph database for like a retrieval step in a GraphRAG workflow, we're always using some index to find the starting point in our traversal. And then we traverse the graph by looking at what nodes are connected based on our starting point, and a vector index is just another way to find the starting point into our graph. So oftentimes having the vector search and the graph traversal in the same system in a graph database can be helpful for simplifying your architecture and just getting started, I think.
Yeah. And there are some vector databases that are adding in some interesting uh, capabilities as well, more advanced capabilities. So, as Will said, maybe it's great to start simple, and I'm a big fan of that. And then if you find you need more, there's one in particular that's going to be adding or is adding multimodal capabilities into their vector database as well, so you can actually store images. So it probably all depends on your need and like how how advanced you need to go. So advantage. Oh, so somebody is asking, like, is there an advantage to using a dedicated vector database versus having it in a database? And it's I feel like this space is moving really quickly, and as Will said, it probably depends on your push pull between how simplified you need your architecture to be, whether you're going to use it just for RAG and GraphRAG, or whether you're going to use it for other capabilities, and you need things like query chaining and things of that nature. So I am a fan of on the open source side. LanceDB has an open source option, and I do like that for just a simple, quick and going, but it's a separate, then you are working with a separate database, which may or may not be something that you want to do. So for time, I didn't realize I was talking so long. For time, I'm gonna move a little bit quickly through the next few slides, because we have a demo, and I want to get to demo. So we did a use case using patient data. This is a link to the where we pulled the data from. This is the schema that we developed. So practitioners, patients, allergies, substance, locations, whether they have immunization. So kind of kind of what you might think of as a classic. We like this because it was actually pretty messy. The data was pretty messy in the entries, so we could use the LLMs to test out some of our theories. But I did want to get to this slide because I think this slide has, a really nice architecture to start with, or I guess a process to start with. So, here we can see the graph is always playing a really important role. And I would call I'm almost thinking like maybe we should stop calling it GraphRAG and just call it hybrid RAG. But the graph is pretty important here. You can see, that, with our starting point, our graph schema, that we don't tell the LLMs to use the entire graph schema. We do a pruning of it. So in this case, the LLM is looking at the question and it is looking at the schema, and it then prunes the schema down to the extracted keywords. And so, for example, if you're asking questions about like a penicillin allergy, you actually select the word penicillin as a keyword, and use that as your vector search. So you do that as your entity keywords. But then you also prune your schema to include, the allergy, things like penicillin, and maybe you prune out the practitioner because we don't care about the doctor. We're just interested in the patient in this case. And so basically, it's becomes a hybrid search query, in front of the vector database. So then it uses the information from both the graph retrieval and the vector database retrieval. And then finally, the system uses a synthesis model to basically inspect the answers from both and then generate a final response from that. So pretty, I want to say simple, but in parallel, we're looking at these different ways of trying to come up with an answer. And this is what I would say is a graph or a hybrid graph workflow. So every individual step, schema pruning, entity extraction, text to cipher, the LLM decides what to do, but this high level orchestration is what we've predefined. And we did this specifically so that we could test each section, and we use mostly OPIC to do that, and kind of figure out where the problems are. Because otherwise, it's a little difficult to figure out like where's the problem in my workflow, and then later add in the automation. And we really recommend starting with this kind of approach where you start with a workflow and deterministically test and move on. I've since yeah, I think people are kind of in general have asked about like usually when I do this talk, they ask about like, well, do I really need a graph? Can I use just a graph? Do I need to have vector? I always include something like this, just to kind of talk about, well, graph rag, or good rag, hybrid rag. It's really about using the best tool for the job and using them together. So using them together, you always get better results because you can incorporate more variability. If we think about the traditional, I'll go up, down. If we're thinking about traditional vector, I'm really good at summarization. Like, tell me about immunization for this particular person or these people. Fuzzy matches, which patients are allergic to seafood. This actually caused us a problem because the database only had shellfish and fish in it originally. So the exact match gave us a null set, and that's no good. And we had people that were allergic to fish, but we asked about seafood. So in this case, vector did really well there. You can use full text search for exact matches. Graph is also good for exact matches, as is structured searches in general. But some of the things that are classically graphy, doing things like dependency searches, topological questions, questions like which patients are eligible for, but not late for a second dose of an immunization in a series. So example is MMR is a multi-dose series that you have to get one after the other, but you can only do it in a certain time period. Otherwise, you got to start over. So there are things like that that graphs are really good at. They're really good at yes, no questions. So, is this doctor treating multiple patients? And they're also good with aggregating over multiple tables if you have to pull in multiple data. So those are, I guess another reason why, graph plus, vector does, even better together. And then I'm going to talk just a little. I think actually looking at the time, I was going to talk a little bit about BAML. If you haven't used Boundaries BAML, That is something that a lot of graph people are excited about. It's a very expressive language. It works really well with graphs and LLMs to get more predictable outputs. I think of it as a parser for structured that enforces structured outputs. And it is really good as prompt engineering is coding. It's very type safe. I'm not going to go into a lot of detail on this. I had some examples, but we can leave that for another time. A lot of my colleagues are also playing with GSPy as well, and has been really excited about it. And because that also allows for kind of this enforcing of type and also encouraging particular outputs. I'm watching very closely. I suspect people are going to be using both of these together, but it does, if you're working with a graph or somewhere where you have to have structured and specific output, definitely look at BAML, look at DSPy, maybe use them together. So I'm going to pause and just say, Will, I've been talking really nonstop, and I know you had a demo, and I want to see a little bit of demo. Do we still have time for that?
For sure, yeah, and I think this is a good tee up for what we want to look at talking about BAML here. So, as Amy mentioned, the patient medical notes data set that she was looking at and the GraphRAG implementation there, that was part of a workshop at was it the Gen AI Summit? One of the
Agentic
ODSC events?
AI Summit. Agentic AI
Agentic,
Summit. Yeah.
right. And that was using what, like Kuzu as the graph database, BAML to extract structured data, and then what was it, LanceDB for the vector? What was the architecture of that
Yeah, it
workshop?
was. You've got it right. And LanceDB for the vector embeddings, and then we used OPIC for monitoring and benchmarking.
Gotcha. Cool. Well, I wanted to use that same data set and similar ideas based on using maybe a little different architecture. So I thought it'd be interesting to see what we could do with BAML and dgraph to put together something similar using the same data set. So this is a look a little bit about like building the graph, and then we'll see how to query it through MCP to expose sort of text to DQL in this case functionality. So here's the repo. I'll drop the link to the repo in the chat if folks want to take a look. But the basic idea is this is the data set that Amy showed earlier, where we have a bunch of free text notes from patient provider interactions. That's the field on the right. On the left, this is like structured data from some like version of electronic health record sort of thing. But I just ignored that and focused on, okay, we have like notes, natural language text. How do we get this into the sort of graph format that we wanted? This is the data model that that my example is using. We have patients, they have allergies, they have immunizations. We have some information about where they live. There's like a geospatial component to this as well. And we're going to use BAML here to extract data in a structured format that we can then import in the graph. So if we look at the code here, maybe we'll just give this a run. Make test full import. This will go through the script and just load a few records. And so we can see here the first thing we do is we load this Parquet file. This is that file on Hugging Face, and we're first processing that text with BAML, and we get this structured parsed output. So how does that work? Well, BAML is really interesting. It's kind of like its own language for working with models. So first we need to define some clients. So we can use GPT-4 Mini with an OpenAI key, or Cloud Anthropic. I think I'm using OpenAI here. And then the next piece is we need to define our model. So like the types. This matches the graph diagram that we were just looking at in sort of BAML's data modeling language. And then we need the prompt. And so we're passing in the medical text. This is the note that we had. And then our instructions are like, hey, extract some information and give us this well-structured medical record format in JSON. And that's basically what we're running here through, I think we're just looking at like the first three notes to get in this structured JSON format, which we can then import into, in this case, dgraph, using the schema that we've defined. And dgraph uses RDF triples to do this. So I think we're going to see some examples in the output here of what those triples look like. But think of that as sort of constructing the individual records that we want to insert into the database. And then there's also an embedding step. And yeah, here we can see some triple examples. And so this one here, this example, if I can zoom in on it, this is saying that a node with this ID lives in a node with this ID. So this is like patient lives in, I don't know, address or something like that. So anyway, that is extracting the data using BAML from the like unstructured notes, loading that into dgraph, adding embeddings, and then the next step is, okay, how do I actually like retrieve or how do I interact with the database to do this? Well, one way is by writing DQL queries. So this is Retel, which is like a query workbench for dgraph. And my graph is running in Hypermode graphs here. So you can see patient graph is active. And let's try to reconnect to this. Grab my connection credentials and then drop that here. I think my graph may have gone to sleep. That's okay.
While you're doing that, Will, or waking it back up, I'll just say one of the things that I noticed when we were extracting, and it probably bear playing with yourself, but yeah, we found that adding descriptors for BAML actually improved the extraction. So you would have like aliases, and alias would be surname, alias, family name, and then we would describe it as surname is a normal given family name, and that just seemed to improve like any kind of a hint to the LLM seemed to improve the results, which I found interesting. I assumed it would already know that, but it actually it helped to give it like more clues.
Does that go in the model definition or does that go in the prompt? Maybe both.
It went in the place we saw it most was actually in the prompt for extraction. So we were looking for, we were basically doing a description of what we were trying to extract. So
right.
you do it
Gotcha.
like, and then
kind of like a few shot example sort of thing.
Yeah.
Cool. That's a good shout. So yeah, it looks like our graph woke up. So here's a visualization of the schema, but we can do things like, here's a query to search for patients that have an allergy and conditions associated with that. So here we can see this patient has conditions shared by these patients that have different allergies. So we can sort of start to analyze the graph that way to see like, okay, what are our allergies shared in common, that sort of thing. And to do that, we're writing DQL, which is the query language that we use for dgraph. But of course, in a lot of these retrievers, there's a natural language step. There's this like text input, right? And just to demonstrate like how the pieces fit together, one thing we can do is leverage tools exposed by MCP. MCP, this is Model Context Protocol, which is a way of exposing tools to agents. And in this case, our hosted Hypermode graph, which is a hosted dgraph instance, exposes its own MCP endpoint. So I've added that in Claude here. So in Claude, I have the Hypermode patient graph, which has access to 5 different tools for like inspecting the schema, running queries, that sort of thing. So I can say what data is in my graph. And now the model, looks like Anthropic is having some issues. So Claude might be down right now. That's fine. I think I have a saved one here. You can see what this looks like. Yeah, here's a previous example we looked at. And so the way the MCP works is that it gives tools to the agent with these like natural language descriptions of what the tools can do, and the model knows, oh, you're asking about what data is in the database. I can inspect the schema.
Nice.
I can look at documentation to help me construct these DQL queries. Of course, like the foundational models are trained on lots of examples, but you can also use other MCPs to sort of augment the model's ability to like search and look at query examples. And so I just kind of asked it for like a basic summary, and it's like going through and look at reactions and this sort of thing. So I think I told it to focus on what was my actual question? Analyze using basic exploratory data analysis techniques with a focus on allergies. And so it ends up with this, like, here's this report of like some of the most common allergies that we're seeing in the data set, the severity distribution, what sort of reactions and common conditions are occurring alongside that. So some way to help us sort of traverse the graph to understand the answer to our question here. Just kind of showing how the pieces fit together a little bit.
Awesome. I love how the tools are chained together. That's really nice to see.
Yeah, I think it's an important way to tie the concepts together, right? Is to actually sit down and poke around at something, and it may not be the most production ready GraphRAG system, but yeah, I think it hopefully gives you a better idea of how you can use different tools together to accomplish the same thing.
Absolutely.
Cool. Well, we are a bit over time, so maybe we will call it a day and stop there. But thanks so much, Amy, for coming and sharing this chat with us. Thanks everyone for joining. Is there anything we should end on? Any interesting things going on in the GraphGeeks community coming up,
Ooh.
or anything we want to highlight before we drop off?
So everybody always thinks is always thinking about like what's next. Graph space is moving really, really fast. So if there's something you're trying to do you can't do now, check back, follow researchers, ping the GraphGeeks community. But probably one of the most exciting things right now is using graph as memory. I mentioned it a couple times. It's not related to specifically to GraphRAG, but I think it's an area that is going to be really important in AI going forward. Will, I know that's something you and I have talked a lot about, and there's some capabilities there that I think you're going to be talking a little bit more about in the future. And I'm very excited to say to everybody, Will is going to be on a GraphGeeks talk in September where we will talk about graph and memory. So thank you for having me, and thank you for actually coming on to GraphGeeks to talk a little more about graph as memory too.
Yeah, that should be a fun one. I'm looking forward to that. So stay tuned. Yeah, for that. Cool. Well, let's end there. Thanks everyone for joining. I saw some questions about the recording. Like, yep, the recording will be on YouTube. We'll share that out, and then also try to write up a blog post summary of this. So look for that on the Hypermode blog. Otherwise, definitely feel free to join us in the Hypermode Discord or in the GraphGeeks Discord. That's probably the best way to follow up with either of us, I imagine.
Mhm. So also, I will see everybody online. Thanks again, everybody. Thank you, Will. Really appreciate it. It was fun.
All right. Thanks.